Quick, a ray of light hits a mirror like this. Which path will it take? Think fast. Most people get this wrong. In this video, you'll learn how to analyze light rays using the laws of reflection. We'll break down what happens when light hits a surface and how to predict exactly where it goes. Step 1. Draw the normal line. It's a line that's perpendicular to the surface right at the point of contact. Next, measure the angle of incidence from the ray to the normal. Then, draw the reflected ray at the same angle on the other side. That's the first law of reflection. Angle in equals angle out. There's a second law of reflection too. It says the incident ray, the reflected ray, and the normal all lie in the same plane. No matter the angle, the rule stays the same. The incident angle equals the reflected angle. It's predictable, precise, and always works for flat surfaces. This is exactly how laser beams are aligned in labs or how periscopes work in submarines. The rule is universal. Many students think the light just bounces straight back. That's not how it works unless the ray comes in at 90 degrees. All right, let's test you. Where will this ray reflect? Pause now and try to draw it. Ready? Here's the answer. Remember, mirror, normal, match the angles. But what if the surface is rough? The laws still apply. But since the surface tilts at many angles, light reflects in many directions. That's why rough surfaces look matte. Now, let's look at image formation. When light reflects off a mirror, the rays bounce off. But your brain traces them back in a straight line. These backward extensions appear to meet behind the mirror. That's where the image forms. It's virtual, meaning light doesn't actually come from there. This virtual image appears behind a mirror is the same size as the object and upright, but it's laterally inverted. That's why your left and right seem flipped. To recap, 1. Draw the normal. 2. Match the angles. 3. The rays and the normal lie in the same plane. 4. Rough surfaces cause scattering. And 5. Reflected rays can form virtual images, which appear real but can't be projected. Ready to quiz yourself with the content covered in this video? Check out the link in the description where you'll find Quizlet content made just for you.